Okay. So next problem we have here. How many moles of electrons are required to produce 0.84 liters of oxygen at exactly 180 and 125 from aqueous H2SO4 solution? And then letter B and letter C, there are three problems. Let's see how long will it take for me to solve one. So anyway, if it already crosses my point, then probably I will not be solving all of this, but maybe I would be. Let's see. So as you can see, this is a gas. Your oxygen is a gas, and it expects that it must come from electrolysis of your solution H2SO4. Okay? So maybe at the gas end, uh, I don't know really what is happening, but me personally, if I will try to make a solution of this, I'll put first the gas law because your oxygen is a gas. We've already talked about gases in environment. So your gas law is a PV is equal to nRT. Your R is given, okay? And then what else? Your volume, your temperature and pressure. Your volume, your pressure, and your temperature is given. So you can get actually N. With this condition, you can get the number of moles of O2 molecule. Actually, that is a PV all over RT. So equating that, we already have number of moles. So from the number of moles of electron, we have to get how many how many electrons would be needed. So basically, you must know that your H2SO4, of course, this is an acid. So we know from our do we look at your table of ions, you can see that your H plus here, your H would be an H plus. So there are two of those, so that would be a 2H plus. There are two hydrogens, and you have a sulfate, SO4 negative 2. Now, the only problem here is because your O4, um, we have to make uh, O, O2, O2. So actually here, your SO4, your oxygen is a negative 2. So negative 2, that would be times 4, that would be a negative 8 for oxygen. So for the whole sulfate to have a negative 2, your sulfur here must be a positive 6. So it means for every oxygen, you have a negative 2 electron, making oxygen, oxide negative 2 to actually, the only information you need, oxide going to O2. So you need two of this. So you need how much electron do you need? So this is negative 4. You must have, this is 0. So meaning you have to supply 4 electrons. 4 electrons is needed for you to have 1 mole of oxygen. This is the problem. So you will use that relationship, your stoichiometry, that it needs 4 moles of electron per oxygen. So 4 moles of electron per mole, 1 mole of oxygen. Since we have already computed the number of moles of oxygen, therefore we can compute that mole of electrons. So we can already do that. Okay? So again, this is from your knowledge of oxidation reduction reaction. At least you can say for every O2 that should be made from oxide, O negative 2, I understand that the problem didn't give you any information. But again, you have to look for your information from the table of ions or from the normal oxidation number. And for oxygen, that is O negative 2. So your oxide is a negative 2, usually. Even in SO4, even SO4, your oxygen there is a negative 2. And your sulfur is a positive 6. Meaning, wala kita pakialam with ibang compound, kaya natin lang pakialam how to make that oxygen from your oxide. and it needs 4 moles of oxygen for every 1 mole of an O2 molecule. Okay? So we do that. So actually, it's already analyzed, so I think it's already solved. So we only have to plug the numbers, 0.84 liters. So you have 0.84 liters. And then how about your pressure? 1 atm, I think, I guess. So you have 1 atm. 1 atm for your pressure. Then your R is a constant 0.082056 liter atm per mole Kelvin. And then your temperature is given, which should be in absolute. Absolute temperature is 25. 25 plus 273.15. So that is Kelvin. Cancel, cancel. Then liters, liters, atm, atm. So we have the mole. Mole of, what is this? That is the mole of oxygen. Okay? So if this is already the mole of oxygen, it will go up because it's the down of the down. Okay? And then we will multiply it by what? For every 1 mole of oxygen, or for every 1 mole of O2, you need 4 mole of electron. Control C. 4 mole of electron. As you can see, that is already solved. Your unit now is mole of electron, which is what is really the problem is all about. So the upper part would be 0.84 times 4 all over your 0.082056. No unit na already, and then you have your 298.15, 298.15, no units. So unit now is mole of electron. Ang dali lang pala. I could solve every problem here. So you have a 0.84 times 4 divided by 0.08200566 times 298.15. So that's your mole of electrons. That is 0.137. So 0.137 mole of electron needed from sulfate, from electrolysis of sulfate into your oxygen. Okay? So how many minutes have already passed? Think we can cut the solution. How many minutes? Where's the minute here? Still looking for the time. Anyway, I could stop recording.